Welcome to Ask and Learn.
We want to find the critical numbers of the function f of x equal 2x cubed plus x squared plus 2x. So first we find the derivative of f, and that function is 6x squared plus 2x plus 2. And this derivative exists at any x, any real number x. The domain, in fact, of the function is the whole real numbers, because this expression, this polynomial, is defined for every real number x. So the domain of f is R, the real numbers, and the derivative exists for every x in the real numbers. That is, these two facts together implies that the only critical points of the function f are those x for which the derivative is 0. That is because, remember, the definition of critical number of a function are the x or values in the domain of the function for which the derivative does not exist, or it exists and is equal to 0. So that's why we look first at the domain of the function, that is, the real numbers, and then we see where the derivative exists. In this case, it exists for every real number, that is, for every x in the domain of the function. Therefore, the only critical points or numbers of this function are those values of x in the real numbers for which the derivative is equal to 0. So the equation we gotta solve is this: if derivative equals 0, and that's equivalent to, looking at the formula here of the derivative, 6x squared plus 2x plus 2 equals 0. And that's the same, taking 2 common factor, we get 2 times 3x squared plus x plus 1. And because 2 is a constant different from 0, this is equivalent to, here is equals 0, and this is equivalent to that the expression inside parentheses to 3x squared plus x plus 1 be equal to 0. That is, the equation we gotta solve is this one here, because solving this equation we have all the x for which the first derivative of the function is equal to 0. So let's find that by applying the formula, or best, we're going to calculate the discriminant of this equation, because it's a second degree polynomial equal to 0. So we use the discriminant expression, which is b squared minus 4ac, where b is the coefficient of x to the 1, a is the coefficient of x squared, and c is the independent term. So in this case, this is equal to 1 squared minus 4 times 3 times 1. That is 1 minus 12. That is negative 11. And because this expression is going to appear inside the square root in the general formula of the solution of this second order equation, we know that with this condition here, we won't have real solutions. Then there is no number x in the real numbers such that 3x squared plus x plus 1 equals 0, that is the same as saying that the first derivative of f different from 0 for all x in the real numbers. And then, taking into account what we said above, we can conclude that this function has no critical points. And that's the final answer of this problem.